This is Mechanical Science Sheet 5, question 3. So, for this problem, we know we start with a velocity of 0. And in our first period of time, we cover 500 meters. In the second, we cover 1,500 meters. And in the final period, we cover 250 meters. So, we know that the first period takes place with constant acceleration from 0 to v. So, we've got an equation here. It says v is equal to u plus at. We know u is equal to 0. So if we arrange this to make a the subject and then set our u to be 0, we end up with a is equal to v over t. So yeah, we start with that and we rearrange it to v over t basically. So our first distance, s1, is equal to half a1 multiplied by t1 squared. If we think carefully about what we just did, we derived another equation for a. So if we put that in, we end up with half v multiplied by t1. So we say that s is equal to 500 because that's what the problem tells us. So we can say 500 is equal to half v multiplied by t1. Then we can rearrange t1 to say t1 is equal to 1000 divided by v, our velocity. So that's our constant velocity we're going to use for the second part. So we know that if we have a distance, it's basically velocity multiplied by time. And we know that our second distance is 1,500 and it's happening at constant velocity. So we could just say 1,500 is equal to v multiplied by t2, which is our second time period. The time period is equal to 1,500 divided by v. For the next part, we can say our final distance is equal to 250, and that's equal to v multiplied by t3 plus half a3 multiplied by t3 squared. So that equation is basically the same one we've been using the whole time. So from there, we can rearrange it to say that our acceleration a3 is equal to v over t3. That's kind of what we did before when we did, like in the first section when we rearranged acceleration. So now we've got an equation for a, we can put that back into here and we end up with vt3 plus half v over t3 multiplied by t squared. And we can rearrange that to end up with t3 is equal to 500 over v. So the final part of this problem is to say that t1 plus t2 plus t3 is equal to 300. And we can kind of see there's ratios here. So if this is 1000 over v, and this is 1500 over v, and this is 500 over v, you get a sort of feel for them being a certain size relative to each other and to v. So we can say that t1 is equal to 2 of t3, t2 is equal to 3 of t3, and basically that 6 t3 is equal to 300. So from there we can say that t3 is 50, t1 is 100, and t2 is 150. And that's the end of the problem.